Okay, Nick here again. Just going to talk to you briefly about charcoal. Now, charcoal chemically is carbon, whose chemical symbol is a C, okay? Strange thing is supposed to happen if charcoal is hot and you add to it steam, which is of course water, which is H2O. And if that's a heat reaction, namely the charcoal is burning, when you add the steam into it, the chemicals change, alright? So the carbon unites with the oxygen. So the O, the oxygen from H2O, joins in with the carbon. Now that liberates H2, hydrogen. So essentially, if I can find a way, designing myself, let's say, a sealed system whereby at the top here we have the gases coming out. That's supposed to represent a tube. My diagrams are appalling. And at the bottom here going in that hole we have air plus steam, H2O. We'll be able to get out the two most important gases for burning if this contains charcoal. Now, if I've understood this right, this will require a different type of burning system. Remember, out of here we're hoping to get carbon monoxide plus hydrogen. This would be another variety of updraft gasifier because the air is going in there and going up. Okay? I'll have to try and find a way of lighting it at the bottom because a lot of these gasifier devices rely upon being lit at the bottom. So I'll have to find a suitable container to do that with that will allow me to have output and input. So I'm going to have to, I don't know, have a look around a junkyard or a scrapyard to do that. And also if I can have some kind of extra hole there in which I can put a flame, then I've got the option of being able to light it there, start the combustion reaction of pyrolysis, as it's called, which will start the production of the two principal gases. Now, people talk about wood gas. So if we're not thinking about charcoal now, we just think about wood gas. Some people say that that is CH4. I think it's CH4 as a chemical signal. But no, that's methane. Which is only in small quantities when the pyrolysis reaction is with wood. But essentially, wood gas predominantly contains carbon monoxide and hydrogen. Now that mixture, I understand, makes up a total of 40% of all of the gases which you'll be burning, being 20% carbon monoxide and 20% hydrogen, with the rest being nitrogen plus some other things. The variety of wood that you're burning is going to have an impact upon the various volatile chemicals which are coming off, such as pine is supposed to provide turpentine, You also do get wood alcohol, which is essentially methanol coming off from wood pyrolysis, apparently. So you can see this is rather an intellectual challenge, especially if you're someone like me who's got the mechanical skills of someone who failed in Lego in school, you know what I mean? Alright, but it's definitely something to think about. Now, when I'm thinking about using wood gas or something coming off, the gases coming off charcoal, the main applications I'm thinking of is essentially heating and cooking, and possibly illumination if gas mantles were to be used as well. But I don't think that would be a good idea. So if you're thinking about using an engine, using it in an engine, then the most reliable type of gasifier works in a different way. It essentially has a container which has the reaction going in it. You got a hopper above, which is full of more stuff which comes down, and it works through downdraft, which means the air starts from above and goes down, and it's drawn down by the fact that an engine will demand the fuel when it needs it. That will create the vacuum which will suck it in, just like a petrol engine will suck the petrol into it as demanded. And that's essentially why, so I understand it, wood gas is sometimes called producer gas because it is produced when the engine requires it. So that's essentially my sum total knowledge, more or less, of the theories behind gasification. There are other styles of gasifier apart from this updraft type system and this downdraft type system. Remember, when we're doing things with cans, these become gasifier stoves. And gasifier stoves only rely upon the updraft of air through the material. So when it's pyrolyzing, when it's glowing and all the rest of it, it's giving off the carbon monoxide and the hydrogen, which then gets reignited by the hot air coming out of the jets. So we've got to make sure we got our head around the basic ideas as to how these things work before we can basically play with them properly. Taking into consideration, we're talking about carbon monoxide. The last thing you want to do with carbon monoxide is have it in your house. So you would need to have your boiler system external to your living quarters. With the flat I'm living in at the moment, the boiler is outside the building in its own little alcove. So that would actually be the kind of setup that you might need. But the plumbing would of course get pretty hectic. So I'm going to have to get, if I want to make something proper, like one of these updraft gasifiers, or one of these downdraft gasifiers, I'm going to have to think carefully as to how that can, how to actually put them together. Also, if I want to use water vapor or steam as part of the reaction to extract the hydrogen and the oxygen from the water and turn the water and use the carbon from charcoal to become carbon monoxide, which is also combustible, I have to think carefully as to how I'm going to get the steam in. The only other thing I suppose I would add to this is that it's posing some interesting challenges. Alright, but essentially that's the basic lowdown as to how it all works in accordance with my studies into wood gasification.